Oldest mineral ever measured on Earth is found in Australia. Some of the oldest rocks still preserving organic materials occur in Western Australia. It's unique because it's a continent that was able to preserve a lot of that geological history because it didn't have a very drastic tectonic history. Yet is a very tectonically active continent. This is the fastest moving continental landmass migrating north at a rate of about 5 to 7 centimeters per year. It's like a big truck on the road running over bumps on Tom Java Plateau, Papua New Guinea, and that's essentially what Australia has been doing so for the past 40 million years.
A lot of times how fresh something is comes across in a color because it's denser, more crystalline, or more porous.
The reason why this rock is rusty is because it had sulfides. When you have a mineral that has reduced iron and reduced sulfur and you put it in contact with the atmosphere and it begins to oxidize, it generates a huge amount of sulfuric acid. There are some places in the world, like there's a place in California, Mount Shasta, in which they dumped all the sulfides in river systems, and the water now in that area has a pH of -3. Now you think pH of 0 is the limit, right? But it's not. Unless you know geology, you cannot understand earth science. What differentiates earth sciences and environmental sciences is our understanding of material properties of earth materials, and mineralogy is what gives us an understanding of the material properties of natural products on Earth. Be very careful. From where I am, it's a nice drop.
Mineralogy side is really interesting. Yeah. It's fun. It's a small department. It means you get to know everyone really well.
So these are little features that you see on a rock like this that if you don't notice, you don't understand the context of emplacement. We can identify minerals by smelling a rock. We can identify minerals by tasting a rock. Unless you understand what minerals occur in which environment, you really cannot understand the processes that actually occur in that environment, how a man-made process will affect that environment.
The reason why I wanted to do geology, I wanted to mix physical sciences with an outdoor sort of aspect, and I thought geology was a very good way of doing that.
Anywhere between 30 and 45% of economic activity, the GDP of Australia actually depends on the earth sciences, on the natural resources sector. Our exporting coal, iron ore, and other commodities combined probably account for 50% of all the commodity export in Australia. Geophysics is quite integrated. We think of geophysics as something quite different from mineralogy, but when we measure the physical properties of earth materials, what we measure is the physical properties of the minerals that occur in that material.
Everyone's expected to have some knowledge of all the different disciplines that you have to deal with. Those of you who haven't done any geophysics before, what geophysics is all about is using the physical properties of rocks to trigger something that we can detect. This other instrument is not measuring the susceptibility directly. This is a magnetometer. This is measuring the effect that the rocks are having on the Earth's magnetic field. In other words, the distortion introduced into the Earth's magnetic field by the rocks.
You want to understand the magnetic properties of the minerals in a large area, for example 5 kilometers by 5 kilometers. You can actually do electromagnetic survey, or you can do a aeromagnetic survey. You can get very, very representative spatial properties with the geophysical tools that we have.
It's going to be a Hornfels or a Cook sandstone.
That's got way more epidote in it than what we had before.
That's essentially why geophysics is so important, because it allows us to understand what we try to do by looking at rocks and minerals, but actually with quantitative tools and applied in a much more representative way.
I like the outdoors, and I guess sort of I like practical things that seem sort of like they easily translate to being useful for society. So yeah,
I sort of hanging on a spring, so when it's plugged in the ground like so, if the ground shakes, you get a relative movement between the ball and the magnet.
the course with Steve's been really great. He's probably been one of the best lecturers I've ever encountered at uni, actually, especially in terms of making concepts that seem, you know, tough for most people quite easy and accessible. It definitely seems like a good university. You know, you certainly, I guess you hear things like, you know, that we're supposedly up in the top 3 in the country, and yeah, you know, you want to get a competitive education.
So what that means is that in most scenarios you see a lot of these refracted waves happening, right?
Yeah, just have a look at 6 and make sure it's hooked up properly.
So possibility is this will be your subsoil rocks. This could be a water saturated soil. Yep. Which will have a velocity of about 1500, and this could be dry soil, which will have low velocity.
That's why we carry our geology field trips, trying to combine mineralogy, the study of formation of ore deposits, the environmental consequences of those ore deposits, and combining all of that with using geophysical tools to characterize the material.